In this video, I will show you more examples on applications of linear equations. One of the common types of problems that you may need to work with are investment problems. In those problems, always keep in mind the formula that interest is a product of principal, rate, and time. Sometimes we'll work only with 1 year, therefore the time will disappear, it becomes 1, so the interest will be principal times rate only. Here I put together the situations that the word problem may present. For example, we may have a total amount of money and split this amount into two accounts. We may invest a portion of this money in first account and the remaining part in the second account. And then the problem can ask, for example, of total interest from both accounts, or the total interest could be given, but we need to find out how much money we put in the first account or in the second account. So that's one type of situation. We'll add the interest from both accounts, and that's the total interest. In some other problems, you may have given information that the two interests from both accounts are actually the same, or how much money I need to invest in the first account to obtain a bigger interest than from the second account. So those are the two main situations. Let's see in an example. Peter invested some money at 3.5% simple interest. Simple interest just tells us that we can use the formula PRT. Okay, so Peter invested some money at 3.5% and 5,000 more than 3 times the amount. So that's the full phrase that we need to figure out. Let's leave it for next time when we read it. This amount of money at 4%. Okay, as you see, we have two accounts, 3.5% and 4%. He earned 1,440 in annual interest. Well, we have given the overall total interest, so we actually have this situation. The sum of interest from both accounts is equal to 1,440. How much did he invest at each rate? Okay, so the question is how much it was invested here and how much over there. Therefore, let's introduce a variable. Let x be amount invested at 3.5%. So that would be x. Then we need to figure out the expression that represents the amount invested at 4%. Well, this expression is written over here up to this point. 5,000 more than 3 times the amount. Notice the D word. This suggests that we refer to the amount of money invested at 3.5%. So the amount is the same as x. Okay, let's analyze this again. 5,000 more than 3 times the amount. That means x. Okay, 5,000 more. More means plus. Then 3 times x. Okay, great. So we have both expressions that represent the amount of money invested at each account. X dollars was invested at 3.5%, and the 3x plus 5,000, this whole thing was invested in the second account at 4%. Now, to connect these two interests with the annual interest that is given, 1,440, we need to add the interest that we obtained from both accounts and equal it to 1,440. This way, we produce an equation that can be solved for x and we'll be able to answer the question. So let's write down this equation, replacing at by a multiplication, because x dollars at 3.5% means we are using this formula. Principal is x dollars, rate is 3.5% that we convert into a number by moving decimal 2 places to the left. So we have 0.035 of x, and since this was annual interest, then the time is 1, we don't have to worry about the t. So this expression represents the interest from the first account, and then we're adding the interest from the second account. Second account is at 4%, so it's 0.04 times the amount of money invested there, which is 3x plus 5,000. This has to be in a bracket, and that equals to $1,440 in interest. Okay, so now we need to solve this equation. Since I see some decimals here, I like to get rid of decimals because it's just easier to calculate. Let's multiply the whole equation by 1,000. Why 1,000? Because I want to move this decimal 3 places to the right. This decimal is only 2 places, but I need to move this dot 3 places. So 3 is larger, that's why I multiply by 1,000. Okay, therefore I need to multiply each term. That's one term, that's second term, and that's third term. Each term needs to be multiplied by 1,000. Well, so this dot goes here. We have 35x plus this dot moves 3 places as well. So we end up with 40 in a bracket. Notice that if we multiply a product by 1,000, we multiply just one factor. The whole product is already multiplied. So if someone will come up with idea of multiplying this number and that bracket as well by 1,000, that will be too much. Just one factor gets multiplied. Okay, and then this number by 1,000 really means I'm adding 3 more zeros at the end. Good, let's release the bracket. We have 35x plus 40 times 3 is 120x plus 4 times 5 is 20, and then we have 3 and 1, 4 zeros. A lot of zeros. Equals 144 and 4 zeros as well. Next step, we collect like terms, so it's 155x equals, and then this is 200,000, and here we have 1,440,000. So when we subtract 200,000, we have 1,240,000. And finally, divide by 155, x becomes 124 and 4 zeros divided by 155. That equals, you may want to use a calculator for this answer, that becomes 8,000. Okay, so we invest $8,000 in the first account. Since the question is how much did he invest at each rate, we need to figure out how much money is invested at the second account as well. So the amount at second account is 3 times x, but x is $8,000, plus 5,000. So altogether is 24,000 plus 5, it's $29,000. Great, so we are ready to give the final answer. He invested 8,000 at 3.5% and 29,000 at 4%. The next type of problems that we'll talk about are geometry problems. Before we start an example from this category, let's review some facts that we're supposed to keep in mind. When we deal with a triangle, the sum of angles in any triangle is always equal 180. So no matter what is the triangle, if we add all the angles, it will always be 180 degrees. We need to remember some main formulas for perimeter and area of certain commonly used shapes. For example, perimeter of a rectangle is 2a plus 2b if one side is called A and the other is B, because we are going twice along this side and twice along that side. Perimeter of a circle, this is actually called circumference, which is equal to pi r. So if you have a circle with radius r, the circumference is 2 pi r. Let's look at some formulas for area. Area of a triangle is 1/2 base times height. So base times height and half of it. This is because base times height would represent area of this rectangle, but we're taking only half of it. You see, this triangle can be seen over here, and that triangle can be seen exactly here. So we're taking exactly half of the rectangle. So 1/2 base times height. The very well-known formula for area of a rectangle or a parallelogram, base times height. So I will draw a parallelogram here just for change. Base could be this one or that one, times height. Height is always perpendicular to the base. And area of a circle. The formula is pi r square. Notice that 2 pi r and pi r squared, they look very similar. We use three signs, pi, r, and 2, pi, r, and 2, except that this 2 has totally different role. In perimeter is times 2. In area, we are squaring r. Area is a two-dimensional measurement. That's why we have r squared, like one r and the other r squared represents the unit of area. However, here we have a single r, so we are talking about linear measurement, just one-dimensional measurement, which is perimeter, the length around the circle, while area of a circle is how much space the circle covers. So that's how you can memorize these two formulas. If we have a square of the variable r, we are talking about area. If the variable r is to the first degree, it means it's linear, so this will represent just the circumference, length around the circle. Here we have a formula for area of one more shape, a trapezoid. It is 1/2 a plus b, which represents average base, times height. Let's see how it looks like. A trapezoid has two parallel lines and two sides. Those two parallel lines are called bases. If I will mark this base A and that base B and the height over here, then let's think for a second how would we calculate area of this shape. If we would take this shorter base and multiply by height, we'll obtain a rectangle that is too small. So its area would be smaller than the area of the trapezoid. If we would take the base b times height, we would obtain area of a rectangle that is larger than the trapezoid. So the idea is to take an average base, which can be represented by this mid-segment here, and then if we multiply this average base, a plus b over 2 times height, we would obtain a rectangle that has exactly the same area as this trapezoid. Why? Because this little bit here, this little triangle that we lost from area by reshaping the trapezoid into a rectangle, we gain over here in the top triangle. And similarly on the other side, the little triangle that was lost in the bottom, we gain in the top. So the overall area of this red rectangle is the same as the area of the original trapezoid. That's why we take average base times height. One more thing to remember, very commonly used Pythagorean theorem. A squared plus b squared equals c squared. This equation is true for any right-angled triangle. So as soon as we hear right-angled triangle, most likely we'll have to use this equation. If one side is A, the other is B, and the longest side, which is called hypotenuse, is C, then if we build squares on each side of such triangle, and we are thinking about area of the squares, total area of the smaller squares will be equal to the area of the larger square. That's what the Pythagorean theorem states. Okay, let's look at the first example. The second angle of a triangle is 3 times as large as the first angle. We are talking about a triangle, we are talking about angles, so the first thing that comes to my mind is we most likely will be using this fact that the sum of angles in a triangle is 180 degrees. Let's read further. The measure of the third angle is 10 degrees less than that of the first angle. So what's important in this statement is that we are referring to the first angle, 10 less than the first angle. How large are the angles? Okay, so we need to find all three angles. Let's read it again. The second angle of the triangle is 3 times as large as the first angle. Again, we are referring to the first angle, which suggests that if we introduce a variable for the first angle, let's call it x, then we can refer to this x, that's the measurement of the first angle. On the diagram, well, let's choose one of those angles to be called x, maybe this one. That will be our first angle. Now let's see in respect to the first angle, what is the expression that will describe the second angle? The second angle of a triangle is 3 times as large as the first. So the expression for this would be 3 times as large as x, 3 times x. Okay, this one looks like it's bigger on this diagram, so let's call it 3x, and that will be our second angle. Finally, the third angle is 10 less than that of the first angle. So the third one must be 10 less than whatever the first was, but the first was x. So the expression x minus 10 will represent the measurement of the third angle, 10 degrees here. Third angle. Okay, so now we have clear situation. We know the expressions that represent all three angles, and we can set up the equation just by following the fact that the sum of angles is 180. So the first angle is x, plus the second is 3x, plus the third is x minus 10 degrees, equals to 180 degrees. Don't forget to write the degree sign. At this point, I will suggest that you stop the video and finish this question on your own. So let's work out this question. When we drop this bracket, we collect all the x's. 3x plus x and plus another x is altogether 5x. And then we have negative 10 degrees equals 180. So bring the negative 10 to the other side. We have 5x equals 180 plus 10 is 190 degrees. And then let's divide by 5. We can write it here. X would be 190 degrees divided by 5, which turn out to be 38 degrees. Notice that we end up in degrees as we're supposed to, so that's a checking point. Yes, we are okay. But x is just the first angle. What about the second angle? Well, the second angle is represented by the expression 3x, so we need to know what 3x is. Well, 3x is 3 times 38 degrees, which is 114 degrees. And finally, the third angle is given by the expression x minus 10 degrees, so that's 38 minus 10 is 28 degrees. Okay, so we have everything done. This is our first angle, second angle, and the third angle. Let's give the formal answer. The three angles are 38 degrees, 114 degrees, and 28 degrees. You may want to double check this. If you add all the numbers, that's supposed to be 180. So check it on your own, please. The following group of problems that we'll talk about are mixture or solution problems. Both of these categories will be solved similar way. So in both of these categories, I will suggest the following table. In the top of the table, let's list percent times the volume. That gives us the content. For example, if we have a solution, the easiest to think of is like salty water. And let's imagine we have 5% salt in a glass of water. So this 5% times the volume, let's say 250 milliliters, that's a glass of water, gives you the amount of salt. So content in this example would be amount of salt. And then you list categories. Could be 2, could be 3 categories that we play with. For instance, we could have this 5% solution and mix it with 12% solution, and then when we put them together to obtain the final solution, well, we may wonder what is the percent solution in the end, or we may wonder how many of each category to take to produce, let's say, 10 liters of desired solution, and so on. So this kind of table should be really helpful in mixture solution problems. Let's see an example. An automobile radiator has a capacity of 16 liters. How much pure antifreeze must be added to a mixture of water and antifreeze, that is 18% antifreeze, to make a mixture of 20% antifreeze that can be used to fill the radiator? Okay, after first reading, I know that this is a solution type of problem. And I know I have two categories of liquid that I'm going to mix. I have pure antifreeze, which is really 100% antifreeze, and 18% antifreeze. And I wish to produce a mixture of 20% antifreeze. The question is, how much of pure antifreeze do I need to use? So let's introduce our variable. Let X be the volume of the pure antifreeze in liters. Then what would be the expression that will represent the volume of 18% antifreeze in liters? Since I want to produce 16 liters of the solution, because the radiator has capacity of 16 liters, the overall volume of 16 liters will include X liters of pure antifreeze. Therefore, the rest of it, which is 16 minus X, will represent the volume of 18% antifreeze. Okay, let's put together all our information in the table. Percent times the volume equals content. We are mixing 18% antifreeze with pure antifreeze. What do we know? The overall solution has 16 liters, so that will be the volume. We are placing 16 liters in this box. Okay, now the pure antifreeze that we are going to use is the unknown. That's our X. So let's place X here. We use X liters of pure antifreeze. Therefore, the volume of 18% antifreeze, as we already figured out, is the total 16 minus the part X. So it's 16 minus X here. Okay, we filled up the column of volume. Now the percentage, that's the easy part. 18% means 0.18 numerically. Pure antifreeze, oh, that's 100%, so it's the same as just 1. And the overall solution, we want to have 20%, so 0.2. Now, what we do, we follow the formula that is given in the top of this table. So percent column times volume column gives us the content column. 0.18 times bracket 16 minus X. And then 1 times X, so it's just an X. And 0.2 times 16. We can figure out how much it is in the next line. Okay, so how do we build an equation? The equation comes from comparing the content. The content in this case is the amount of antifreeze. So in the whole solution, we have the antifreeze that comes from 18% antifreeze and the pure antifreeze, that means the entire amount. Okay, let's write down the equation. 0.18 times 16 minus X plus X equals 0.2 times 16. Again, we can use the strategy of getting rid of decimals. So we would like to multiply the whole equation by 100. So that will be 18 times 16 minus X plus 100 times X over here. And multiplying by 100, 0.2 becomes 20 times 16. So 18 times 16 is 288 minus 18x plus 100x equals 320. And then put together the x's. 100 minus 18 is 82x. And 320 minus 288 is 32. So finally, after dividing by 82, we end up with x equals 32 over 82, which could be simplified to 16 over 41 in exact form, but it will be probably more useful if we round it to the nearest, let's say, 2 places. So this is approximately 2.39, and we are in liters, so 0.39 liters, which is about 0.4 of a liter, a little bit less than half a liter. Okay, let's give the answer. The question calls for how much pure antifreeze needs to be mixed, but in this particular problem it will be probably more useful to give the answer how much pure antifreeze and also how much 18% antifreeze needs to be used. Okay, so pure antifreeze is the X, so it's about 0.39 of a liter. Of pure antifreeze needs to be added to approximately how many liters of 18% antifreeze. Let's calculate on this side. 16 minus 0.39 is 15.61. So approximately 15.61 liters of 18% antifreeze we need. Okay. And the last type of problems that we'll talk about are motion problems. Those are so common problems, you will see them in every single math course. So as soon as you recognize that you deal with a motion problem, keep in mind the golden rule, rate times time equals distance. We always refer to this formula, rate times time equals distance. And the table that I would suggest here will be built using this formula, rate times time equals distance. And then you may have different situations. Let's say some object may move with the wind or against the wind, or go forward or backwards, or go by the same road. So you may have different situations, either situation 1, situation 2, sometimes even situation 3. For example, 3 parts of the trip. However, most often will be just 1 and 2. And then final row is the total, because sometimes we are going to add distances, and then the last row will be needed. But sometimes the question will compare the two distances, and then the last row won't be needed at all. So it depends on the question. Let's see the possible situations. Your two objects, so for example 2 cars, may go in different directions starting from the same place. So in this case you are adding the two distances to have the overall distance. Similarly, in the situation when the two objects are going towards each other, again we are adding the two distances to have the overall distance. But also we may have a situation that, for example, one object goes one way and then comes back using the same road. So in this case both distances are equal. It could happen some other situation. For example, one point will move faster than the other during the same time. So in this case we may be interested in the difference between the two distances. So it's a good idea to draw the diagram like this to figure out the situation described in this particular problem. Let's see our example. A Coast Guard patrol boat travels 4 hours on a trip downstream with a 6 miles per hour current, like on the picture. The return trip against the same current takes 5 hours. Find the speed of the boat in still water. Okay, so what kind of situation we have? Exactly this. We're talking about the same distance. So in this case, the last row won't be even needed. We are not adding distances. Since we need to find the speed of the boat in still water, and we also have the 6 miles per hour current, it's a good idea to draw the overall speed. Let's say on this diagram, let's the downstream be actually this way, and let's this arrow represents the 6 miles per hour current. If the speed of the boat is called r, then the overall speed of the boat that moves downstream is this r plus the current 6. However, if the boat comes back with the same own speed r and the current is still going backwards, then the overall rate of moving the boat forward is actually r minus 6. Okay, let's introduce our variable r. Let r be the speed of the boat in still water. Therefore, what expression represents the downstream speed of the boat? Downstream means this way. We're using the own speed of the boat, but the current is helping by adding 6 miles per hour to it. So the overall expression will be r plus 6 miles per hour. While when the boat goes upstream, then the overall speed of the moving boat will be r decreased by the speed of the current, because the current is stopping the boat. Okay, let's fill up all the information in our table. The downstream rate is r plus 6. The upstream rate is r minus 6. The time needed to go downstream is 4 hours, so we place 4 here. And the time needed to go against the current is 5 hours, so we put 5 here. We have no information about the distance, but maybe we don't need it. The only thing that we do need is the fact that the two distances are actually equal. So our equation will come from comparing these two distances. And in this particular problem, we actually don't need the last row at all. So let's figure out the expression for the distance covered downstream. It is rate times time. Okay, so we need to multiply these two columns. 4 times r plus 6 And here in the second row the same 5 times r minus 6. And these two expressions must be equal. So let's set up the equation. 4r plus 6 equals 5r minus 6. Let's release the bracket. We have 4r plus 24 equals 5r minus 30. Okay, if I bring this 4r to the other side and subtract from 5r, I get r by itself, and then bring the 30 to the left and add to 24, it's 54. Therefore, the on speed of the boat in still water is 54 miles per hour. Let's give the final answer. The speed of the boat in still water is 54 miles per hour.